Hello everyone. So in this video lecture I'm going to explain you process state in process management. Okay, in previous video we have seen what is process and what is process model. In that video session we have included child process, how to kill certain process, and that means which system call is used. So that is kill system call and fork system call, which is used to create child process. Okay, in window there is no concept of a process hierarchy, but that means window treats all the process with equal priority. Okay, and there is a handle which is labeled to each and every process whenever it is created, and we do all the controlling. I can say we access certain parameters using this handle. Now let's go to this process state. Okay, let me give you one example over here. In Unix Linux CMD, I am just executing this command. The command is cat chapter 1, chapter 2, chapter 3 pipeline grep tree. Now this cat and grep grep, these both are the commands that are used in Linux and Unix operating system. Okay, so if you are familiar with it, then it's okay, but if you are not, then let me just give you one single simple statement. Okay, so cat command is used to read content of a file. So basically in first command what I am going to do is I am reading content of chapter 1, chapter 2, chapter 3, which are files. Okay, and in second command, that is grep tree, grep command is used to find particular substring in file. Okay, so I am just going to read content of these 3 files, and after that I will perform search operation, that means using grep command. Okay, so whenever I execute this command, basically there are 2 processes will be created. Okay, and first one is cat process and the second one is grep process. Okay, now for cat process, input is these 3 files. Okay, and what will be output, as this command is just reading input of content of a file. Okay, so output text of the 3 files in the console. Now this text of 3 files, it will be considered as an input for this grep command, and output, that means a line with tree string, it will be displayed in your console. Okay, so what I want you to understand is that first of all, answer me, is these 2 processes are different? Yeah, it is different, but is this process are communicating it with each other? Yes. How? So answer is, in this cat process, whatever the output is given as an input to this grep process. Okay, so cat process will read the content of these files, and grep process will find tree substring in that content. Okay, so if speed of this process is relatively if the speed of this cat process is faster than grep process, okay, then it will be okay. But if speed of grep process is very high, then what will happen at some time? It may be possible that this process, cat process, is not even started yet. Okay, that means output is not generated and still this process is ready. So what will happen? This grep process, it will be blocked temporarily until output of this process is on console, or output of this process is ready. Okay, so over here you can see how whenever 2 processes are communicating or multiple processes are executed, then it may be possible that some process are running, some process are blocked depending on other process. Okay, so let's move to the next slide. So in process state, basically whenever process is actually allocated to the CPU, that means process is actually using the CPU, so we can say that process is in running state. Okay, for example, let's say cat process is running right now, that means it is in running state. After that it comes ready state. In ready state, process is runnable temporarily stopped to let another process to run. So in ready state, process is ready to be executed. Okay, but still CPU is not allocated to this process because CPU is already executing another process, but this process is ready. Okay, after that, blocked process is unable to run until some external event happens. For example, some interrupt generate, or if it was waiting for input by user, then if it get this specified input or specified resource, then now this process is ready to execute, and it will transfer its state to ready state, and now this process is ready to be executed. Okay, so basically total there are 3 states: running, ready and blocked. Running, that means CPU executing this process. Ready, that means it is ready. I am ready, sir. Okay, for example, let's say for submission, you are ready for submission, but I'm already conducting viva of other students. Okay, so you are ready, but you have to wait for some time. After that, block state. Okay, so some students just forgot their file. Okay, so they just go back to their home, and so they are not available because they have no file. Okay, they are waiting for their submission files. So till that time they cannot be executed. Just like that, I'm just giving you example. Okay, try to understand this. After that, the whole moral of the story is the process are always either in running state or in ready state or in blocked state. Always these 3 states are primary state. Okay, now let me give you another example. Okay, of window. For example, in window, I am just opening this file, window Microsoft Word file. So over here right now I am not just running this process, but I will create a new process, and then this process will be in running state. So it is in ready state. Okay, first of all it is in ready state. After that, over here this is running state. Okay, so process is running. Now if I want to print this document, okay, so over here you can see this the window at the back end, it is blocked, and it will be blocked until you just don't click on this OK button, or this pop-up will be disappeared. After then it will be activated. Okay, so this is blocked, and once again it is ready state. Okay, now let's see process state transition. Okay, now transition, that means in which situation, what are the situations in which process change its state from, let's say, running to ready, ready to running, or ready to blocked, or blocked to ready. Okay, so let's see. Okay, the first one is from running to blocked. When this kind of situation occur, so process blocks for input or wait for an event. In that kind of situation, process, it can be transferred from running state to block state. For example, process want to read data of certain file, okay, which is right now not available, so it will be just blocked for some time, and once it get its resource, it will be ready to execute. Okay, after that the second state is from running to ready state. Okay, so in this, scheduler picks another process. Okay, so for example, right now CPU is executing certain process. Okay, let's say process A, and once time span of this process to be executed is completed, then this process A is transferred to ready state. Okay, so this is from running to ready. Okay, this process is yet not completed, process is not finished yet. It still requires CPU for its further execution, but it is not completed. Now after that, okay, these are the reason, for example, end of a time slice or a preemptation. Now the third one is scheduler pick this process. That means for CPU, CPU is free, let's say free, and there are total 3 processes which are ready to be executed. Okay, so scheduler will just pick up this process, pick up any one process from these processes, and this transition is referred to from ready state to running state. Okay, transition 4, okay, which is from blocked state to ready state. Once a process which was waiting for particular resource to be available, it available, then process transfer its state from blocked to ready state. Okay, and just keep in mind, never ever process can be transferred from blocked to directly running. Okay, if process is blocked and once it get all needed resources, then it compulsorily it will transfer to ready state, and after ready state scheduler will pick that process and CPU will be allocated to this process. Now let me explain you 5-state process model and transition. So that was a 3-state. Okay, so now let's discuss 5-state process model. So new, that means process is being created. Whenever process is just created, so it will considered as a new process. Okay, and after that, once it get all the resources available for its execution, that means process is ready, or I can say it is a temporarily stopped to let another process run. Okay, it is just waiting for its turn to come and to get CPU. After that, the dispatcher will just pick up, scheduler will pick up any ready processes, and dispatcher will send it to the CPU. It will select the process. So this transition refers to from ready state to running state. Okay, and once time out for that particular process, so again it will come to ready state. After that, if certain event, for example, if this process require input, okay, user input or a certain file or something, waiting for some event to happen, then it will transfer to blocked state. Okay, which is unable to run until some external event happens, and once event occur, it is again transferred to ready state. After that, the last one is exit state. Okay, and the process, if process has finished the execution, then it is in exit state, and finally process is completed. Okay, so this is all about process state transitions, or I can say process state. Okay, very easy. You just need to watch this video carefully with totally awareness just one time. Okay, so I hope you enjoyed this video. Bye bye.